So for our project, we did a solar tracker, and the people in our group were Yevgeny Posnov, Matthew Schaefer, and Tin Nguyen. For our project description, we have a solar panel mounted to a dual-axis mechanical system with light tracking capabilities. The solar panel output voltage and the power are measured. The temperature of the environment is also monitored. The real-time measurements are displayed on a website, and the temperature, voltage, and power can also be data logged into a comma-separated format. For our dual-axis mechanical system, we use 2 servos, a parallax propeller board, an external power supply, and a solar panel. We had to create a structure in which one servo was at the base for horizontal movement and one servo was on a vertical surface for the vertical movement. The servos were calibrated based off the values that the 4-quadrant light tracking circuit were generating. We found that there was a threshold of about 1 unit of how accurate they were, so we used that as the threshold to determine which way the servos would rotate on either axis. The servos were coded to move in 5-degree increments because we found that it was the best variation between moving too much and too little. There are pauses between the readings of the servos so it can move and then read the new values and continue correcting from there.
For the 4-quadrant light tracking, we used 4 separate RC circuits with a photoresistor in parallel with the capacitor. From there, we used the RC time function on the propeller to measure the decay time. Since the photoresistors were all a little different, we had to calibrate them by dividing them by a constant value so that when they were under a controlled lighting environment, they all received the same reading. From there, we took the average for the top, the bottom, the left, and the right readings, and we did a difference between the top and bottom and the left and right, and those 2 values were sent to the servo to determine which way each servo needed to turn. So for the solar panel measurements, we had a single resistor in series with a solar panel. That means all the power generated by the panel gets dissipated by the single resistor. To measure the voltage over the resistor, we used the propeller analog to digital conversion, and to calculate the power from the voltage reading, we did voltage squared divided by the resistance of the resistor, and those readings were sent to the website. For the temperature sensor, we used a thermistor in an RC circuit as well. I had to take resistance readings at a range of temperatures, and then I used the Steinhardt-Hart equations to derive just to derive an equation for the resistance versus temperature of the thermistor. I also used the RC time function to measure the decay time, and from that we could calculate the resistance, which then correlates to a temperature, and that is also sent to the website.
For the communication between the Raspberry Pi and propeller, we use serial communication, the process of sending data 1 bit at a time. First, we load program into the propeller 2 and then connect it with the Raspberry Pi using the micro USB cable. We also use Python script on the Raspberry Pi to send data from the propeller 2 and save it into a text file. For website and data login, we use WebSocket, an internet communication protocol that allows the client and server transfer information without any need of refreshing the web page. We host the website using Node.js. An open source server environment uses JavaScript. We also use Socket.io, a JavaScript networking library that can run with Node.js and for real-time applications such as real-time status update that we use in this project. For future improvement, we need to study a mechanical system. For the calibration of light sensing and temperature sensor, solar panel can be used to power something. Further website development and better wiring.
So now we will demo the solar tracking. We will be using a flashlight for this. So if I shine the light from this side, turn this way. So go right.
Just so many some people do.
Next to go left.
With this one here and the second one, it's considered touching.
And that's how it works.
He knows.